So most of the things that you've studied is basically just stuff that you did in O levels as well, which was redox reactions. You figured out, I mean, what you studied was that there's a thing called redox reactions. We're going to revise that. Now we're going to study redox reactions in A2 as well, but there's going to be a difference. Previously, what happened was that you just did basic stuff, like you knew what reduction was. Reduction was a gain of electrons, right? Now, if something gains electrons, that was considered its charge would decrease, oxidation state would decrease when it would get reduced. And then you also related it to the gain of hydrogen atoms or the loss of oxygen atoms. Okay, in organic chemistry, it made a lot more sense if you talked about gain of hydrogen or loss of oxygen atoms. So that was your concept of reduction. I mean, the proper definition is that it's a gain of electrons. That's the proper definition, and oxidation is the exact opposite. So when you talk about oxidation, it's everything. Just make it the opposite. So starting with the first one, it's a loss of electrons. So that one is a loss of electrons. What happens is that the oxidation state increases. And you also relate it's a gain of oxygen or a loss of hydrogen atoms. Okay, but the proper definition is that it's a loss of electrons. Okay, that's your proper definition for. Also, make sure a lot of people get confused when they try to figure out oxidation and reduction. Make sure the last part, that oxidation state decreases. Like for example, if you go from like this is, let's say, +3, this is +2, this is +1, this one is 0, then you have -1 and so on. Just extend it like so -1, you got -2, and then you have -3 and so on. I just remember this, that if you go from so if you're going in the downward direction, that's reduction. If the charge is decreasing. Vice versa, if you're going in the upward direction, that's going to be oxidation. Okay, which is fairly obvious. But people make mistakes, a lot of mistakes when they're doing this. So this is oxidation. I'll give you an example. What is this? Cl goes from -7, let's say -1 to -4. So what has happened here? Oxidation or reduction? क्या हुआ इसमें? that that's reduction. And how many electrons exactly were gained? See, that's specifically a gain of just difference in color. That's a gain of 3 electrons, right? I said, what happens? I said, what's happening here? Reduction or oxidation? Gain of electrons, loss of electrons. Let's make your way. Anyone. Just wait 1 second. That's the loss of electrons. You get charge increase. And that is oxidation. And that's a loss of exactly 1 electron. Okay. Just make sure, I mean, people mess this up. Okay. Just make sure, be careful with this. Reduction literally means the charge getting reduced, whether it's from +3 to +1 or 0 to -1 or -2 to -3. If the charge is getting reduced, that's reduction. If it's going up, that's oxidation. Okay. Make sure you remember that. That's anyway. So again, basic things. You've studied redox equations, where both things, I mean, all redox reactions, both things happen simultaneously. If one gains electrons, the other loses electrons. So, but I'm going to focus on this word oxidation first. Okay, there's a thing called oxidation state. And we're going to revise that quickly. Oxidation state is that it's the charge on the atom or the element. So it's the charge on the element if the compound or molecule is were ionic. Remember, so it's a hypothetical charge. It's a hypothetical charge on an element. It might be the real charge, but remember, oxidation state only tells you who's gaining electrons, who's losing electrons, and it depends a lot on electronegativity of the element. It does not tell you whether the atom is gaining the electron completely or just slightly. It just tells you that the atom has gained electrons. So it depends on the electronegativity of the species that you're talking about. So if you've got a periodic table, which side is the most electronegative? It's the one in the top right corner. Electronegativity increases to the right, it increases to the top as well. So this is the corner which is more electronegative. Okay, this side is the place which is the most electronegative side. Whoever over here is, that's the one that's electronegative. So as the reason oxidation state is not the actual charges, it can be the actual charge. For example, in NaCl, you got NaCl. Now the difference in electronegativity is so large that the Cl actually ends up gaining the electrons, and sodium actually ends up losing the electrons. The electrons are completely gained by Cl, the one that's more electronegative. So the oxidation state of Cl is -1, which is also the actual charge of Cl as well. But if you take another molecule like a covalent molecule, HCl, now in HCl, Cl does the same thing. It does the same thing, but it's the difference in electronegativity is not that large, which is why what happens is that Cl only slightly gains the electrons. So Cl gets a slight negative charge. It's a polar molecule. Cl gets a slight negative charge, and the hydrogen on the other side gets a slight positive charge. Okay, so I've given you two molecules. One of them is ionic, where the atom actually ends up gaining the electron. The other one is covalent, where the difference in electronegativity is not that large. But when we talk about oxidation state, we don't care whether the electrons are being gained slightly or whether they're being gained completely. So when we talk about oxidation state, हम इसको भी -1 दे देते हैं. We assume that the Cl has gained electrons. We don't care whether it's gaining the electrons slightly. The electrons were over here. Now they're closer to Cl, so Cl has gained the electrons. So the oxidation state is going to be -1 in both cases. Hydrogen will have an oxidation state of +1. Na will also have an oxidation state of +1. So the oxidation state is not telling you whether it's gaining the electrons slightly or completely. It just tells you that the Cl is the one that's gaining electrons. And it doesn't tell you whether the other atom has lost the electron completely or whether it's only losing the electron very slightly. So the oxidation state simply tells you that the other atom is. So it's +1 over here, +1 over here as well. Okay, so your difference clear? Is this clear? Anna, is this clear? Okay.
Yes, sir.
Okay, so just remember that oxidation state is the same thing. Oxidation state is slightly different than charge. When you talk about charge, the charge is actually slightly negative. Oxidation state is just who's gaining electron. That's it. Completely or not completely. That's a different story. So anyway, so you can use the oxidation states to figure out. You can use the electronegativity table to figure out the oxidation state of elements. If I have a water molecule. So who's more electronegative? It's oxygen, right? Oxygen will gain these electrons, although slightly. Oxygen will gain these electrons as well. So in total, it's going to gain 2 electrons. It's going to be -2. And H will be the one that would be losing electrons. So it's going to be +1 over here, and it's going to be +1 over here as well, right? But if oxygen is with a more electronegative element, like fluorine is the most electronegative element. Now who's gaining the electron? It's fluorine that's going to end up gaining the electrons, right? So fluorine would be -1 and fluorine would be -1 over here, and oxygen would end up losing 2 electrons. So it's going to be +2. Okay, so is this clear? Are those examples clear? Okay, you can use electronegativity to figure out oxidation state. Clear? Well, so we can do another example. Like if I have an F2 molecule. So who ends up gaining or losing electrons? Now in this case, the electronegativity is the same. So that means no one ends up gaining or losing these electrons in the middle. So the oxidation state would be 0 on both of them. Okay, because there is no difference in electronegativity. No one ended up gaining electrons. No one ended up losing electrons. If I have an H2O2 molecule, this is what an H2O2 molecule looks like. So how many electrons will oxygen gain? It's definitely going to gain the electrons from H. It's more electronegative than H. This oxygen as well, it's going to gain electrons from H. In each one electrons, no one is going to gain those electrons or lose those electrons because on both sides you've got oxygen atoms. So they have the same electronegativity. So oxygen ends up gaining just 1 electron. So it's -1. This oxygen is -1. H ends up losing 1 electron. So that's +1. This one is +1. The middle one, no one ends up gaining or losing those electrons. The middle one. So these are examples. Are these clear? So But remember, electronegativity is your fallback. If you don't if you can't figure out, use electronegativity. But the better way of figuring out oxidation states is just using the table, which is that you can remember the oxidation states of certain elements. So we're going to write down the table, which you already know of, hopefully. Okay. In the table, what's given is that neutral elements their oxidation state is always 0. So oxidation state is always zero. Okay, that's for neutral elements. So if you see carbon, or you see Cl2, or you see sodium, all of them have an oxidation state of 0. Then you have compounds. So for compounds, what's going to happen is that, remember that oxygen is usually -2. With plenty of exceptions. Why do I say it's usually -2? Because oxygen is one of the most electronegative elements. So if you combine oxygen with anything, it's going to gain 2 electrons because it's one of the most electronegative elements. How fluorine it's different. Like if you combine it with fluorine is one of the, it's probably the only element which is, actually remember you have the Pauling scale as well. So you can Pauling scale, that's same as you've got the Pauling scale, which still is not there. Just a second. So this one, you've got the Pauling scale. Okay, so the electronegativities are given over here. Oxygen is the second most electronegative element, so it's usually -2. That's the reason why it's always -2, because it's always going to be gaining electrons from other elements, except for fluorine. So or consort, the hydrogen is usually +1. I said there are exceptions. I'm going to write down the exceptions as well. So except in H2O2, the one example that we did above, or with F. Pure consort, hydrogen is usually +1. So it's usually +1. If you look at the table again, sorry. So if you look at the table again, hydrogen is over here. It's 2.2. So hydrogen is less electronegative than pretty much all the non-metals. So when you combine hydrogen with any of the non-metals, they have a greater electronegativity. I mean, this corner, the non-metal corner, they're all more electronegative than hydrogen. But not with metals. If I combine it with sodium, then sodium and hydrogen would be the one that would be gaining electrons, because hydrogen has an electronegativity of 2.2. Sodium has an electronegativity of 0.93. So ye zyada hai, that's more electronegative. So in this case, hydrogen would be the one that's going to end up gaining electrons in this case. In GCB, it's more electronegative, so it's going to gain electrons. It's more electronegative than aluminium as well. So the thing is that it's usually +1, but with non-metals, right? and it's -1 with metal hydrides. So when it forms a hydride with a metal, it's going to be -1. Okay, ये भी clear है? So that's why hydrogen is kind of in the middle. It's more electronegative than metals, but it's less electronegative than non-metals. Okay, clear है बात? बाकी basic stuff है कि that's so individual charges. Fluorine is always -1. Remember that. And who else? Now, group 7, you can't really tell whether it's -1 or +1. They have variable oxidation states. Okay? A lot of elements will have variable oxidation states. And also remember this point that individual charges. So individual charges on an element or simply individual charges add up to the total charge on the molecule or compound. Remember, electrochemistry is a big topic. This is just basic stuff which you've already covered. So individual charges add up to the total charge on the compound. So how do you figure out the charges on the things that are not in the table? If oxygen or hydrogen, so what about the other stuff? So the other stuff would be that let's say I've got ClO -1. Now the -1 is on the whole thing. So how do I figure out Cl's oxidation state? I don't know what Cl is, so I'm going to take it as X. Oxygen, I'm sure of, that's -2. And the total charges, they should add up to be equal to -1. Okay, that's the total charge. So X would come out to be equal to +1. So Cl over here is +1 and O over here is -2. Is that clear? You clear? क्लियर है इसमें और एक वर्कशीट कर लेते हैं छोटी सी के yes or no, see this is clear. This is a good question, that's all. Achha, so you got achha, we're going to do some questions. And we're going to move towards balancing redox equations as well. Okay? So they can start with just a few questions. Okay? So we're going to quickly try and find out oxidation states of different compounds. So let's try and do this for HNO3. So kya hoga? That's H is +1. Remember that. What's so H is +1. N is, we're not sure what N is. That's X. And O is -2. And there are 3 of them. And it's a neutral molecule, so everything should add up to be equal to 0. So what is N now? Yeah, but then that's what do we get for that? +5. So we're getting +5 for this one. So N is +5 over here. You can remember the missing ones. H and O we already know. Let's do another one, H4P2O7. So that's +1 times 4. Then I've got P2, which is 2x. I don't know what P is. O is -2 times 7. And the whole thing has a neutral charge. It's equal to 0. Isme kya bana? What's X? H and O I'm sure of. B I'm not sure.
5.
5 is sure. The -14 foregone. Okay, that's 5. That's also 5. Achha, so I of 4 minus 1, I'll just do another one. Okay, I of 4 minus 1, that's I is unknown, that's X. -2 times 4, that's oxygen. And the total charge is equal to -1. So that means it's coming out to be +7. Okay. So iodine has a charge of +7. And I'll also explain a bit why iodine has a charge of +7 over here. Okay, what does +7 mean? Okay, just a little bit in detail. Okay, if I can find the dotted cross diagram of IO4 -1. As I found this. So this one, this is, where's the structure? Let's try this one. And this is what iodate looks like. Okay, it's not IO4 -1, and this is IO3 -1. Okay. Now what happens here is that if you look at this molecule, who's more electronegative? It's oxygen that's more electronegative, right? So what happens is, I said, who's more electronegative? It's oxygen that's more electronegative. So what happens to the electrons over here? These two electrons, these are with the oxygen. These 4 electrons are also with oxygen over here, and these electrons are also with oxygen. So in total, how many electrons is iodine losing? It's 2 over here. Apne kitne lose kar hai? 2 electrons gone over here. 2 electrons gone over here. 2 electrons gone over here. It's losing a total of 6 electrons, but it's got a -1 charge. So that means it's gaining 1 electron back as well. There's 1 extra electron. It's got 8 electrons. So that means it had 8 electrons, out of which it lost 2 electrons here, 2 electrons here, 2 electrons over here. So in total, it's got an oxidation state of +5. You can remember that it's gaining 1 electron as well, -1 charge. So electronegativity ka bhi karke you can figure this out, but that's a lot easier. But moving on, I'm going to move towards redox equations. Okay, we'll just do the basic stuff and balancing redox equations. The first thing, I mean, you can figure out the oxidation state. Yeah, that should not be an issue for you now. But balancing redox equation. Now remember this, when we start this chapter, every time a redox equation has to be balanced this way. Okay, this is something that's very basic. So what's the rule for balancing a redox reaction? That the number of electrons that are gained and lost, they must always be equal. So electrons gained should be equal to the number of electrons that are lost. That's the key. So if I have a redox reaction, I've got sodium reacting with Al3+, and you're going to get Na+1, and you're going to get Al. Okay, that's the reaction. Now it's a redox reaction. Who's getting oxidized? It's Na+1, and it lost how many electrons? It lost 1 electron. And who's getting reduced? It's Al3 plus going from 3 plus to 0. That's a gain of 3 electrons. Is that clear? So you lost 1 electron, you gained 3 electrons, and they've got to be equal. So what you're going to do is you're going to multiply Na by 3, because right now the electrons gained and lost are not equal. So you're going to multiply Na by 3. That will make the number of electrons gained and lost equal. Is that clear? Clear? Umar, clear? Shan, is this clear? Question? Yes, sir.
Yes, sir.
And remember, there are two methods of doing that. Okay? I mean, it's a simple equation right now. Just make the electrons gain and lost equal. Think of a number, multiply both of them with that particular number. In this case, with this one would be multiplied by 1. So you don't have to do anything. And that would be multiplied by 3. Now, every method has a certain limitation. There's another method as well, which does the same. And that method is that you make the charges on both sides equal. I said, example. Let's say I've got. Yeah, I'm actually going to discuss this in a lot more detail. We'll do a lot of difficult questions. Okay? I'll do another one. Let's say I've got Mg. Na displaces Mg, right? So I've got Na and it's reacting with Mg plus 2 ions. So Na is more reactive. So there's this reaction where Na turns into Na plus 1 and Mg gets reduced. So Mg becomes just Mg. As a plus 2 to 0, that's come on, plus 2 to 0. You're going down, right? Plus 2 to 0. Decreasing reduction, that's a gain of 2 electrons. And Na goes from Na goes from all the way to anyways, Na goes from 0 to plus 1, so that's increasing. That's a loss of electrons. That's it lost 1 electron. So Abdullah, you have to make the number of electrons gained and lost equal. This is losing 1 electron. This one is gaining 2 electrons. So you're going to multiply this by 2 and multiply this by 1, which means that you should have 1 Mg and you should have 2 NAs. Because 1 Na was only losing 1 electron. 2 NAs would lose a total of 2 electrons. Now the number of electrons that are lost and that are gained are equal now. Okay, clear? But don't worry, I'll do a lot more questions right now. Okay? This one is one of the. Just a second. उसको break कर लेते हैं कि just a second. देखो, first thing, in a redox reaction, so there's a redox reaction happening, right? Okay, let's focus on this. I said, forget the reaction. The reaction is already with you. Okay? They've given you a reaction. There's a reaction happening. In redox reactions, what happens? Someone loses electrons and someone ends up gaining electrons, right? So what is happening? Sodium is the one that's losing electrons. You know, clear and Abdullah. Okay, sodium is going from 0 to plus 1. It lost an electron and there was Al3 plus. And that Al3 plus turned into Al, that gained electrons, right? So someone is going to lose electrons and someone else is going to gain electrons. In this case, sodium is the one that's losing electrons, Al is the one that's gaining electrons. Okay? Now the clear, sodium lost 1 electron and Al gained 3 electrons. So is that part clear?
सर एक दफा और समझा दे.
ये वाला part के sodium lost 1 electron. ये तो clear है ना? And Al gained 3 electrons.
Yes, yes. ये तो clear है sir.
अच्छा. So the point is कि if Al is supposed to gain, इनको अलग कर लेते हैं. यहाँ पे. I've got Al3 plus and I've got sodium. What's happening in the reaction? Well, what's happening in the reaction? Sodium lost 1 electron. Al gained 3 electrons, right? So I'm going to write it over here. So this one gained 3 electrons, right? And this one lost 1 electron. The question is, how can it gain 3 electrons if that is only losing 1 electron? The number of electrons that are lost should be equal to the number of electrons. If one of them is gaining electrons, the other one is losing electrons, then it has to be equal. Like, how can it gain 3 electrons if that never lost 3 electrons? So कितने sodiums होने चाहिए? If you have 3 sodiums, then the total electrons lost would be 3 as well, because each sodium would lose 1 electron. Is that clear? Okay, now it's balanced. If I said that sodium in a reaction lost 1 electron, and sodium is always going to lose 1 electron. One sodium atom is going to lose 1 electron. And in the same reaction, Al3 plus is gaining 3 electrons. Now, it's not possible that one loses 1 electron, the other one gains 3 electrons. It has to be equal. So I would multiply sodium by 3. ये बात clear है कि sodium को 3 से multiply करना है? That clear है? So is that clear?
Yes.
Because it's not going to be possible that sodium lost 1 electron, then how can Al gain 3 electrons? That's not possible. Okay? So what you have to do over here is once you've figured out this one is losing 2 electrons and this one is gaining 3 electrons. Once you've figured that out, this number has to be equal. And the only way you can make that equal is you can multiply any one of them with some number. If I multiply this by 3, that would make it equal. So that means I should have 3 sodiums. And over here I have 3 sodium ions. Now that number is equal. We had the same issue over here. Mg went from plus 2 to Mg. It gained just 2 electrons, right? Just 2 electrons were gained. But sodium went from sodium to sodium plus 1 and it lost 1 electron. So in this case, if I rub this off as well, the equation was unbalanced. Why? Because how can Mg gain 2 electrons if Na never lost 2 electrons? Because the number of electrons lost and gained, they have to be equal at all costs. So what you're going to do is you're going to make these two equal. So multiply the first one by 2. So you should have 2 sodiums. Because if you have 2 sodiums, then the total electrons lost would be 2. And those electrons are going to be gained by Mg, because Mg wants to gain 2 electrons as well. समझ आया ये? Okay, remember in every redox reaction, the number of electrons gained and lost, they have to be equal at all costs. So the first part is just figure out who's losing electrons, who's gaining electrons. Once you figure that out, multiply them with a certain number so that the number of electrons lost and gained, they become equal. Okay. If Al is supposed to gain 3 electrons, you need 3 sodiums because each sodium loses 1 electron. So 3 honge, so there would be a total loss of 3 electrons, right? You clear? Is this part clear? This one? Abdullah, did you get this? We'll do more questions tomorrow, okay? We'll do more difficult questions as well tomorrow, okay? On the same thing. Tomorrow is Friday. We'll have class tomorrow. So we'll continue. Because it's, I mean, that's what I'm saying. Okay, like you got sodium and you got Al, which is 3 plus. I mean, these are the two things that are reacting, right? Sodium is losing, I mean, without balancing, sodium is just losing one electron. It lost just one electron, right? It just lost one electron. And you said that in the reaction, Al3 plus is gaining 3 electrons. So the basic question is, the reason it's unbalanced is, how can Al gain 3 electrons if sodium never lost 1 electron? There are two people standing. One of them is giving 1 electron to the other one. And the other one says that it's gaining 3 electrons. That's not possible, right? Because if this loses 3 electrons, then it will gain 3 electrons, right? So there's going to be 3 sodiums. That's the only way a total of 3 electrons are going to be lost. Okay, clear? Is this clear?
Yes.
So plus, we'll do more questions on this. TK, we'll just remember this thing, basic thing in all redox reactors. I mean, this is very important. TK. Someone is going to gain electrons. In this case, Al. Someone is going to lose electrons. But the number of electrons gained and lost, it has to be equal. TK, it's not possible that this gains 3 electrons when the other one never lost 3 electrons. TK. So it can only gain 3 electrons if the other one is also losing 3 electrons. I said, but we'll do more questions on this. TK. So we'll continue tomorrow then. TK. Is that okay, everyone? Take care. Allah Hafiz.